Okay, this is chapter 10. This is the chapter on probability. By far, my favorite aspect of math. I love probability. It's fun. It's games. It's the part of math to me that's exciting. So, hopefully you get excited about this too. Probability. Does anybody here know what probability is?
Like probability guessing?
What is it?
Chances of something.
Right, chances, right? Like what is the chance of something happening? That's what probability is. You know that every day your parents and even probably you deal with probability and you don't even realize it. Every morning I have to make a decision coming to school. What do you think my choices are?
Go straight to school or go to Starbucks?
Maybe, but what else? What else?
Walk or drive?
Sure. Say I'm going to drive. I have a couple of choices. I can go
Highway. Left or right?
I can go the freeway, or I can go the back roads. See, if I go the back roads, I know exactly how long that's going to take me. It's going to take me 23 minutes to get to school. If I go the back roads, guaranteed. If I go the freeway, I can't go to the back roads anymore. So if I go the freeway, if there's no traffic at all, it might only take me 15 minutes. But if there's a lot of traffic, it might take me 30. So I have to decide, what am I going to do? Am I going to go on the freeway and take a chance at it being not very much traffic? Or am I going to go, and maybe getting there to school early? Or am I going to go the back roads and know it's going to take me 23? Does that make sense? I'm dealing with probability. And I know that about half the time there's a lot of traffic on the freeway. And so I have to kind of weigh this. You know what I'm talking about? To weigh it. I don't know, what am I going to do? I'm deciding on it based on probability. There is, if I was to ask you guys right now, okay, we're going to, whatever. I said pick a number between 1 and 10. So it's Caleb, it's between you and Donovan. And I said, what number are you going to choose? Between 1 and 10?
7.
7. What number should you choose?
1.
No. What number should you choose? No. What number should he have chosen? Between 1 and 10. He chose 7. What number should the next person choose? Sladen?
7.
No. Somebody already chose 7. What number? 6. If you don't get that, then I will explain that to you in a little while after we do this for a little bit, okay? Because that's a very obvious answer. It's a very obvious answer. Okay. Anyway. We're going to start this chapter with what's called the counting principle and tree diagrams. Let's look on page 476. I want you to read a few things with me. Okay, we're on page 476 where it says, why learn this? A coin toss is used in sporting events to decide which team starts with the ball. Right, you watch the football game, they flip a coin, see who gets the ball. If you toss a coin once, there's 2 possible outcomes, heads or tails. Agreed? Okay. An outcome is the result of an action, right? An outcome is what can happen, right? When I flip a coin, what are the possible outcomes? Head or tails. You all understand that? When I flip a coin, the possible outcomes are heads or tails. When I roll a dice, what are the possible outcomes? 1, 2, 3, 4, 5, or 6, right? Make sense? Okay. An event is an outcome or group of outcomes. The set of all possible outcomes is the sample space. I'm not too worried about those things. I'll explain it here in a second. Finding the sample space. Use the menu at the right. Construct sample space for selecting a main dish and a side dish. How many possible outcomes are there? So here's the deal. Here's our box, right? Here's our guy. And inside we have, there's the main dish, main and side. And in the main you've got grilled, right? And or baked chicken. And then you have a salad, a vegetable, or rice. Now, here's the deal. What are my total possible, if you were going to order 1 main and 1 side, how many total possibilities are there? How many total different things are there to possibly order? Well, let's look. I could get grilled chicken with a salad. I could get grilled chicken with a salad. I could get grilled chicken with what? A vegetable. I could get grilled chicken with rice. Or I could get baked chicken with a salad, baked chicken with a vegetable, or baked chicken with rice. You see what I'm talking about? How many total possible combinations are there in this at this lunch place? 6. There are 6, right? 6. So, let's do this. Now that you know that, you guys try this. Look at number 1 at the bottom. Answer number 1 for me, okay? We'll go over it in a second. I want you to try and answer number 1 for me at the bottom of page 476. All right, so here's the deal. The question says, a bicycle comes in 3 models and 3 colors. Doesn't matter what the models' names are. Doesn't matter what the colors are. We can make up anything we want to. Let's just do this. But for the sake of our doing this so you can see, we're going to call it Model A, Model B, and Model C. Do you agree that it could be one, could be a whatever. It could be a little kids model, an advanced model, and a super exotic, awesome model, right? Or whatever. A, B, or C. It doesn't matter what they're called. Okay? In each, there's 3 models, and there's also 3 different colors. Black, red, white, whatever, right? Could be anything. Let's choose colors. Let's make the colors be color number 1, color number 2, and color number 3. Does it matter what I call them? No. So with model A, how many different possible colors can I have? 3. So there's A, and then there's A1, A2, and A3. So look, I want you to look at this. Oops. We'll go like this. There is one. Why is that like that? Okay. There's one possible combination, A1. Another one would be A2. Another one would be A3. Does that make sense? So Model A, color 1. Model A, color 2. Model A, color 3. Agreed? Do you see that? Are you seeing it? Yes. B. Right? B could come in color 1. B could come in color 2. B could come in color 3. C could come in color 1. C could come in color 2. C could come in color 3. How many different possibilities are there, or what is the sample space for 3 models, 3 colors? Juna, how many? 9. 9, right? You have a question?
Why can't you just multiply?
You can do anything you want to. I'm showing you so that you can visualize it, right? Are you all following this so far? Yeah. Okay. Here's the deal. A tree diagram is what I just did. A tree diagram is what I just did. Watch. It says you roll a standard number cube. Oh, wow. They used a very fancy word for a dice, right? A standard number cube, or a dice. You throw 1 die and toss a coin. Okay? You throw a die and you toss a coin. Are we paying attention? Mm-hmm. Throw a dice and flip a coin. List the possible outcomes. List the possible outcomes. Well, then here's the deal. Here's what you do. You have to make, you're going to start branching off here. What are my possibilities? What are the possibilities here? Tell me, with the number cube, with the dice, what is the possibilities? What is the possibilities? I can roll a 1. I could roll a 2. I could roll a 3. I could roll a 4. I could roll a 5, or I could roll a 6. Do you agree? Right? I could do that. Once I've rolled the 4, let's say I roll it and it becomes a 4. Now what else do I have to do? Flip a coin. Okay? Once I roll a 1, I'm flipping a coin. The 1 can be with a head, or it can be with a tail. Right? If I do both, here's my dice and here's my coin. I throw both up at the same time. They come down. It could come up with a 1 and a head, or a 1 and a tail. Agreed? It could also come down a 2 and a 3. It could come down a 2 and a head, or a 2 and a tail. It could come down a 3 and a head, or a 3 and a tail. It could come down a 4 and a head or a 4 and a tail. It could come down a, you guys are starting to get it, right? 2 and a head or 2 and a tail. 3 and a head or 3 and a tail. 4 and a head or 4 and a tail. 5 and a head or 5 and a tail. 6 and a head or 6 and a tail. How many, listen, anytime I take a dice and a coin and I throw them up in the air, how many total possible outcomes are there? There are 12 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you all see that? That's called that's a tree diagram. Okay, that's a tree diagram. I'm going to show you this. I'm going to show you another one. Actually, I want you to do one for me. Okay? Here's the deal. You have a cat at home who's pregnant. Okay? Cat's pregnant, and you know the cat has 2 babies. Okay? The cat has 2 babies. I would like for you to use a tree diagram to tell me what are the possibilities for her having 2 babies, right? Boys or girls? You know what I'm talking about? Using a boy or a girl, what are the possibilities of her having 2 babies? Use a tree diagram. It's a simple one. Okay, so your cat has 2 babies. They're twins. One comes out first, another one comes out after that. Here's the deal. What could possibly come out first? What could possibly come out first? A boy or a girl. Right? A boy could come out first or a girl could come out first, right? Right? For the second baby cat that comes out, what could possibly come out? Oh, a boy or a girl. Oh. If a girl came out first, then what could possibly come out? Oh, a boy or a girl. How many different possibilities are there when you have a cat have 2 babies, right? 4, right? A boy and then a boy first, or then a boy then a girl, or a girl then a boy, and then a girl then a girl. Does that make sense? Does that make sense? All right, try this one, okay? It's going to be a little bit more, it's going to take a little thinking, okay? At a, restaurant, we'll say, whatever, at a diner, whatever, they have, here we go, they have for lunch, they have a main dish, they have a side dish, and they have a dessert. I use this, how do you spell dessert? D-E-S-E-R-T, or is it 2 S's? I think it's 2 S's for dessert. Okay. The main, you might be right, I don't know. Good thing I'm not a spelling teacher. Okay. The main dishes are chicken, beef, or pork. Oops, or pork. Okay. The side dishes are either rice or potatoes. And then the dessert is either ice cream or cake. When you go to this restaurant, you're going to have to choose one of each. Okay? I'm asking you to find the sample space for going and getting lunch at this place. Or tell me, another word for saying finding the sample space is what is the total number of possible outcomes that you could possibly do. Okay? That's what I'm asking. Figure it out for me using a tree diagram. All right. Stop what you're doing. See if you're even doing the right thing here. Okay? Really, stop. Watch. Here's the deal. They have to order 3 different things. Agreed? What is the first thing they have to order? A main dish. The main dishes, and listen, when I say give yourself some room, watch what I mean. The main is chicken, beef, or pork. See how I made that kind of wide? The next thing, what do they have to, if they order chicken, what do they have to order? What do they have to decide next? The side. It's either going to be chicken and rice or chicken and potatoes. Do you see what I'm talking about? With beef, it's either beef and rice or beef and potatoes. With pork, it's either pork and rice or pork and potatoes. Make sense? Okay. Now, listen, I'm not going to finish this. I'm just going to go like this. Now that I have done this, I've chosen those two things. I now have other options, right? What else do I have to choose? Ice cream or cake. So if I chose chicken and rice, now I have to choose between cake or ice cream. Cake or ice cream. There's one possible outcome is chicken, rice, cake. Or chicken, rice, ice cream. Do you see it? Okay. Chicken, pork, and what? Or ice cream. Or chicken, pork, and cake. There's chicken, potatoes. Right. I understand what you're saying. Do you see what I'm saying? Once I've chosen chicken, there's 4 options for me, right? Same thing with down here. Down here, I am going to go, if I could choose beef, rice, and cake, or beef, rice, and ice cream, or beef, potatoes, and cake, or beef, potatoes, and ice cream, or I could have pork, rice, and cake, or pork, rice, and ice cream, pork, potatoes, and cake, or pork, potatoes, and ice cream. How many total possibilities are there in the sample space? 12. Do you see them? Now I will show you an easier way of doing this, but you have to understand why you can do that. There's 4 here, 4 here, 4 here. There's 12. Right? Do you see them? Do you get it? Okay. Here is the other way of doing this. No, I'll just erase it. Okay. The other way of doing this is to use what's called the counting principle, and that is that if 3 things have to happen, you have to choose a main, side, dessert, right? How many mains do I have to choose from? How many sides do I have to choose from? How many desserts do I have to choose from? What's 3 times 2 times 2? 12, right? 12. You need to be able to visualize it. That's why we use the tree diagram. But you can do it by just going 3 times 2 times 2. I promise I'll explain that as soon as we get to that part, right? Look at page 477, the last question, very bottom, number 3. In the menu above, cherry ripple ice cream as a flavor and fudge as a topping are added. Find the new number of different desserts. Well, notice that. Let's look at the first example, number 3 up there, where it says choose one. It says there's flavors. How many flavors are there over there? How many flavors are there? 5 flavors. How many toppings? 3 toppings. And how many different cones? 2. Right? Are you looking at it? How do I use the counting principle here? If you have to choose 1 flavor, 1 topping, and 1 cone, how do you use the counting principle? Multiply 5 times 3 times 2. What's 5 times 3 times 2? 30. The answer would be C. Do you see it? Are you all with me on page 477? Yes. So, now you do number 3 at the bottom right now. Do number 3 at the bottom of the page. Answer the question. All right, so listen. They said here, in the menu above, cherry ripple ice cream as a flavor and fudge as a topping are added. What is the new number of different desserts? What did you do different this time? So what do I do instead? Instead of it being 5 times 3 times 2, I'm going to go, what? 6 times 4 times 2. What's 6 times 4? 24. 24 times 2 is 48. How many of you got 48 different flavors? I believe that you should not have any problem with any of this. Look at page 479. Well, let's do this. I have a quick question. I'm going to make a spinner. I want you to do something here for me. Here, hold on. Okay. Here's the 1, 2, 3, 4, 5, and 6. What is if I spin this thing, if I spin that spinner, I'll give a little spinner arrow here. There's my arrow. If I spin this spinner twice, what is the sample space? If I spin this thing twice, what is the sample space? Or what is the total number of possible outcomes when I spin this thing twice, Sladen? No. No. When I spin it the first time, what are the possibilities? What are the possibilities when I spin it the first time? What are the possibilities? 1, 2, 3, 4, 5, or 6. If I spun a 1 the first time, now I'm going to spin it again. What are the possibilities of me? What are the possibilities when I spin it? 1, 2, 3, 4, 5, or 6. So I could spin a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, and a 1 and a 6. Or I could spin a 2 and a 1, a 2 and a 2, a 2 and a 3. What am I going to do here, people? What's the counting principle? Listen, 2 different things have to happen. How many possibilities are there when I spin the dice the first time? 6. I need you guys to listen and listen. Follow me here. I've got a spinner. I'm going to spin it twice. When I spin it the first time, how many possibilities are there for me to spin? 6, right? I now have to spin it a second time. When I spin it, how many possibilities are there for me to spin it a second time? 6, right? Can't I spin any of those numbers again? So 6 the first time and 6 the second time. What do I do with those? Multiply them. What is the sample space of spinning this thing twice? 36. Do y'all understand? I could go 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, or 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, or 3, 1, 3, 2, 3, right? One last one. What about this? Here's a coin. There's George Washington. Okay. I'm going to flip that coin twice. What is the sample space of me flipping that coin twice? 4. There's 2 possibilities on the first one and 2 possibilities on the second one. What do I do with these 2 numbers? Multiply them. Right? 2 times 2 is 4. What if, I need you to get this. If there is I don't know. When you go, today in the lunch line, there's different types of pizza, right? How many different types of pizza were there in the lunch line today? 3. 3 types: pepperoni, sausage, and cheese, right? How many different drink types do you have when you get a drink from them? Yeah. What kind of drinks can you get? Name them. You got water, lemonade, apple juice, milk, right? 4. Water, lemonade, apple juice, milk. Okay? Water, lemonade, apple juice, milk. What is the sample space if you go to lunch and you get a piece of a piece of pizza and a drink? What is the sample space? 12. 3 pizza possibilities, 4 drink possibilities. 3 times 4 is 12. Are you following that? Okay, your homework.
it.
That's it.